So today we're going to talk about parallel and perpendicular lines. Okay, in other words, when we have two equations, sometimes they behave a certain way. Okay? So in this case, I mean, title kind of gives away. I hate giving titles sometimes. It doesn't give you a chance to explore. Okay, so we can talk about now. Okay, so you have questions about it? Ask them. All right. So first of all, describe these two lines. So that's the first question. How are they related graphically? Right? What do they look like? Tyler?
They have the same slope.
Well, that's going on a little bit. Just graphically, though. What is it? So you see that they have the same slope just graphically? Yeah, okay. I can kind of see that. Right? But what the gist is that they're parallel, right? So that we're going to get tied to, yes, they're going to be having the same slope. But here we have two lines that look parallel. So how can we come up with the equation for, let's say, the one in blue? We could come up with the equation for the one in blue.
To find the slope.
No, I want the equation in this line. That's question number B. Right? How can we get the equation of this line? Well, what's the first thing we might start off with? Well, even before that, just start with the equation. We've only learned two forms of the equation of a line, right? What were those two forms? Standard, which was what, Michael?
A, B, C, 0.
Yeah, ax plus by plus c is equal to 0. Was that equation helpful whatsoever? No, it was nice when we did the x-intercepts and the y-intercepts using that equation, but it doesn't tell us anything about the characteristics of the line, right? What was the other one that we learned? What was the other form that we learned? Sorry? Y slope, y-intercept form, right? Which is? Tell me this is hooked up. There we go. So y is equal to mx plus b, right? Just take that first step. When it asks for an equation, just write that down. Okay. Now what are the two parts that we need to look for? Yeah, the slope and the y-intercept. Okay, so how can we get that with the blue one? Which one do you want to do first? The y-intercept, Andrew? Okay, so what might that be?
0.2.
The y-intercept?
Yeah,
We're looking at the blue line. And we want the y-intercept, which means what? What value is 0?
X.
Yeah, x, right? So we're looking down here. So what's our y-intercept, Andrew? So it's 1. Okay. So y equals mx plus 1. Okay. You don't have to go solving both of them at the same time. Just take our step, take our time getting there. How can we calculate our slope? It's a little bit more challenging part. That one?
You find 2 points.
2 points at what?
Just pick like 2 points.
Any 2 points? So I'll pick this point over here.
That will like it's recommended that it's like on the line, so it's a whole number.
Yeah, so it's like on one of the crosshairs, right? So looking at, I'm not sure how clear it is on this picture, but looking like that one might cross. So we have our 2 points. We're going to use our y-intercept as the other one. How can we calculate the slope? Now we have our 2 points. How can we calculate our slope? Aaron? Okay, so we could do slope over here is delta y over delta x. So yeah, you could do y2 over 1. I like Michael's suggestion better. We just count them on here because we just got a graph, right? Nothing's labeled for us. We don't have any points, right? So I could go through the extra effort writing down the points, but I could just count them what Michael says. Okay. So what's our delta y here? So in other words, what's our rise? What's our rise on this? Tyler? 5? 1, 2, 3, 4, 5. Yep. And what's our run? 1. So our slope is just really 5. So we got y is equal to 5x plus 1. Okay, so that's how we come up with the equation with the blue one. How about the red one? What are we going to start off with? What are we going to just start off with? Well, before that,
Oh, the equation.
just write down the equation, right? Y is equal to mx plus b. Just a general form of our equation. And again, we want to figure out what our m is and what our y-intercept is. So Carson, can you tell me what the y-intercept is on this one? Where does it look like it's crossing the y-axis? Look on yours, so maybe we'll see better on yours. Where is it crossing the y-axis? So which one's the y-axis again? The one goes up and down or left and right?
Vertical.
Vertical, right? So that's the y-axis. So where is it crossing there?
1.
At 1? It's crossing here?
No,
We're on the red line.
We're on the red line. Look at the red line. I know I can't tell on your sheet. It's the one on the right. So where does it cross the y-axis on this one?
-7.
2, 4, 6. 2, 4, 6. Yeah, that looks like -7. So here it's plus -7.
You see it.
Yeah, but I just want to write out explicitly that's what our b value is -7, right? But Michael's right, we don't want to leave it in this form. What, mx minus 7. Okay. So again, how are we going to calculate the slope of this one? Yeah, so it looks like this point here is another exact point that's hitting the crosshair. So here the rise is, so the slope is rise over run. And here the rise is what? 1, 2, 3, 4, 5. And the run is also 1. So therefore our equation is y is equal to 5x minus 7. Okay, so Tyler's already hinted at us as, well, I wrote the equation each way, so we'll read it again. Y is equal to 5x plus 1 was the red one. And y is equal to 5x minus 7 was the red. So Tyler already hinted that, well, how do these two equations look similar? What values they're the same? Veronica? Yeah, here we see that the slopes are the same. So here are the slopes of both lines. Are the same. Okay? So we see that when that happens, we do get the parallel lines. That's how you can determine that two lines are parallel, just by looking at their slope. And I think this is for you guys written down already under the summary. So two lines are parallel if they have the same slope. So you can tell just from the equation the two lines are parallel. Okay? Hopefully you already know that parallel lines they never cross one another. I mean, that's for sure. They're equal distance away from each other.
Yeah, what's this?
The symbol for parallel lines is just two parallel lines. Okay. So there we might say that line 1 is parallel to line 2. Okay, so that's how we actually write that. So let's go through some quick examples. So I have two lines here. How can we determine they're parallel or not? So who says that they're the same? That they're parallel? Raise their hand. Who says they're not parallel? Raise your hand. Okay, Carson, why do you say that they're parallel?
Because they have the same slope.
How do you see that?
Well, on the 4y, you have to change it back to the y, and then it's 80 divided by.
Sorry, for this one?
Yeah.
For that line? That equation?
Yeah.
Yeah, so that one isn't in slope-intercept form, right? Actually, it's in not even in standard form, it's just a different form. This one is. So what's the slope of that one? What's the slope of that line? 2. Well, we need to convert this one into slope-intercept form. So here we got 4y equal to 8x plus 3. So to convert to slope-intercept form, what are we really doing again? Three words. One of them is actually a letter. Isolating for y, right? Which is why y by itself. Isolating for y. That's how we get to slope-intercept form. So here, how can we isolate for y? Cambridge, how can we isolate for y on this side?
Divide by 4.
Yeah, so we divide by 4 here. So back, go to your equations, and do one thing on one side, you need to do it to the other. So we need to divide the whole thing on the other side by a half. I mean, divide by 2.
Why?
Sorry?
4.
Apparently my 4 look like a y.
No, like the other side isn't
Oh,
supposed
sorry. Yes, supposed to be divided by 4. I'm thinking ahead to the answer already. That's my problem. So here we got y is equal to 8x plus 3 over 4. So again, does that look like our slope-intercept form? So there's one addition that we do want to make. I mean, this is y is isolated, but we want to break up those two parts. So here we got y is equal to 8x over 4 plus 3 over 4. Now we're left with just y is equal to 2x plus 3 over 4. So now we see that the slope of this one is 2. And that matches our slope up here. So yes, they are parallel. Slopes of both lines is 2. Therefore, they are parallel. So a little bit tricky, but all we're looking for is just converting both to the same slope-intercept form. Y equals mx plus b. So here it's a little bit harder question. Find the equation of the line parallel to y is equal to minus 2x minus 5 that passes through 1, 2. How might we start doing that? So first find the coordinates 1, 2. Good. So we have the coordinates 1, 2 here. But how do I get which line that goes through there? There's lots of lines that go through it. Think about what the question is asking. Find the equation of the line parallel to y is equal to negative 2x minus 5, passing through 1, 2. Well, how can we get the y-intercept?
Place
Sorry?
put negative
So the y-intercept is negative 5?
Yeah, no.
So y-intercept is negative 5. But that's the y-intercept of this equation.
It's not over here.
No, read the question.
Oh, okay, yeah.
We want to find the equation that's parallel to this line, y is equal to negative 2x minus 5. So in other words, we want to find the line. So let's first of all, let's graph this one. Negative 5, what's our slope?
Negative 2.
Negative 2, so I go down 2 over 1, down 2 over 1. So this is, if that was a straight line, that's that line. What we want to do is we want to find a line that's parallel to this, but it passes through that point. So this line, of course, is not going to pass through that point. We could visually see that, right? But we want a line that's parallel to it, that passes through 1, 2. How do we begin to do that? Only given a point. Right?
Since the slope is negative 2, just go up 2 from that point and then 1 to the left.
How do we know the slope is negative 2 for that first equation?
It's parallel.
Yeah, okay, so say we want a line that's parallel to that, so what do we know about parallel lines that have the same slope? So here, whatever's going to pass through here, I'll do it in red, this has to have a slope of negative 2. Not negative a half, negative 2. Okay, so that's what means that we want a line that's parallel to that. So here, we could do a slope of negative 2. So we go down 2 over 1, down 2 over 1, right? And here we could draw our line. So I'm not going to risk it. You guys have the advantage, you have a ruler. Alright, I'm going to draw a straight line. From here, passing through there. Okay, the question wasn't draw the equation, draw the line that's parallel to it. How can we get the equation of this line then? How can we get the equation of this line? Abby? Good. So we start with y is equal to mx plus b. Well, what's one thing that we know already? The slope. So it's y is equal to negative 2 x plus b. So what's the value of b then? 4?
Yeah.
Yeah, it looks like it's 4. If we did a slope calculation over here, instead of going down 2 and to the right, we could go up 2 and to the left, and that would have put us at that point. So this would have been 0, 4. Okay. Sometimes it's hard to guess, especially if you don't draw your lines perfectly, see where the y-intercept is. So ideally, you want to do your sloping to get back to the y-intercept, so you can see exactly where it crosses. Okay. Any questions on that? No? So the tricky part was just getting the slope from the other line, right? It gives us a hint, it's parallel to this line. So two lines that we want, two lines that are parallel. Any question, Abby? Yeah. So I want to take some time to show you how we could have solved this another way, even without the graph. And notice that you guys don't have a graph. I put that in here just to demonstrate it, because I knew that's where you're probably going to veer off initially. We want the equation of the line. What do we start off with again? Just our equation, y is equal to mx plus b. Okay? So now that we determined, well, what's the slope of this line going to be? It's going to be -2. So at y is equal to -2x plus b. So we got that information from this equation of another line that's parallel to it. Here, we're given another piece of information. It passes through 1, 2. So again, what does that mean to equation of a line? What does that mean in a relationship? When we have 1, 2. When x is 1, y is 2. If a line passes through that, what does that mean again?
That's a point of the line.
That's a point on our line. Exactly. So 1, 2 is a point on our line. But what does that mean algebraically? So we can kind of see that if we draw this line, 1, 2, it passes through that. But what does that mean algebraically? You guys remember? Talked about this a little bit before. So if we go back into our equation, so if x is 1, right? So we have that point 1, 2. If x is 1, then what's the value of y? 2. That's what that means when it passes through that point. A line passes through that point. That means when it's 1, 2, when x is 1, when independent value is 1, the resulting value is 2. That's what we see by that linear relationship. So here, and 2 gets into there. So when x is 1, the value of y is 2. And now we can go off and try to solve for b. So here we get 2 is equal to -2 plus b. And add 2 to both sides. And left with b is equal to 4. And we saw that we got the same thing. So therefore our equation is okay. So you can determine that algebraically as well. And it's a way more accurate to try to graph it and draw a line and see where it crosses the y-intercept. Let's keep.
Does the black writing represent the black line?
No, I just did it different colors because this was one method. So this is we did by graphing. So we solved that one by graphing. In this method we did by algebra. But both go to this black line. They're both solving for that black line. Okay. Any other questions? Okay, we'll go through a couple of quick examples. Find the equation line that's parallel to y is equal to 2 and passes through point 5, 6. So you can always try to visually see this. What does the line y is equal to 2 look like?
That's horizontal.
Vertical?
That's horizontal.
Yeah, y is equal to 2, that means it's horizontal. So we want a line that's another horizontal line because it's parallel, but passes through 5, 6. So because it's parallel, what's our slope?
2.
Well, what's the slope of this line?
Oh, 0.
0. So we don't have the x. Well, where is it going to be passing through the y-interceptor?
2.
Well, it's going to pass through this line, 5, 6, right?
Yeah.
So where's our y-intercept going to be? So we visually graph this,
Oh.
right? Here we have y is equal to 2. Right? We have a point up here, 5, 6, might be something like that. Right? So we want a line that's parallel to the red one that passes through this green point. So what's that line going to look like? Well, what's that line going to look like though? It's a horizontal line. Right? So where's the y-intercept of that? 6. Right? It's just our y value. Right? It's just our y value. So here's just y is equal to 6. Okay. So on the flip side, we have an equation that's any line is parallel to the vertical line which passes through 3, 4. So what's the equation of any parallel line? I'm sorry, any vertical line look like? So vertical line, what's that equation going to look like, Tyler? Yeah, so it's going to be x equals something. The one vertical line, so that means it's going to be x equals something, right? Because no matter what the y value is, it's going to be x equals something. It's the vertical, that same value. So here's going to be x equals
3.
3. Just pull that from there. Okay, so a couple of special cases with horizontal and vertical lines. Right? But the idea is that because we know they're parallel, their slopes are the same. We're still getting the same information. Here we have a slope of 0. And what's the slope of these lines? What's the slope of these lines that are vertical? Undefined, remember? Undefined. Okay, now we'll look at something a little bit different. Throw lines are kind of boring. But so we like this graph. I think it's on the back page. So how would you describe that about something about these lines? Just by looking at it, how can you describe these lines? Good, they cross. So where are they crossing? So right around here, right? So they cross. Or the word that we like to use in math is called they intersect. Right? That's where the term intersection comes from. Like streets intersect. Intersection. So they cross. What else can we say about these lines? How are they related? Alan?
They have the same x value.
What do you mean they have the same x value?
Like they have the same x intercept.
Oh, so you notice that they're crossing right at the x-intercept. So here, they have the same x-intercept. Good. Anything else? Aaron? Yeah, it's kind of hard to tell, but what we're trying to do in this thing is that basically there's a right angle there. They meet at 90 degrees. Okay? So here's a right angle, that means this would be a right angle, that would be a right angle, that would be a right angle. Okay? So we have two lines that are intersecting at 90 degrees. 90 degrees is something that's very special on that. You'll learn lots more about it next year. triangles and stuff like that. But 98-degree angles have a special property. We're going to focus a lot on that later on. Okay? Well, later on in future years. So let's do the same thing. Let's find the equation of these lines. So how about the blue one, which is going across this way. So again, how do we start? By figuring out the equation again? Colleen? How do we start by getting the equation again? What's the first step we want to take? So which one is that again? Good. Alright, let's start off there. Right? So do that. So which one do you want to tackle first with the blue one? Y-intercept? Yeah. What does it look like on there? Yeah, it looks like 1 to b 2. So here we got y is equal to mx plus 1. How are we going to deal with the slope? Yeah. I'm looking at it here, it looks like it crosses there. And so my rise here is 1, 2, 3. Run is 1, 2, 3, 4. So my slope here, my rise is equal to 3. My run is equal to 4. So my slope is 3 over 4 plus 1. Okay? So that's our equation of a blue line. Or for you guys, the one that's going up. How about the red line? So we're going to start off again, y equals mx plus b. Okay, so let's look for the y-intercept. What's the y-intercept on this one? -2. Yeah, it looks like it's -2 here. So y is equal to mx minus 2. How about our slope? Looks like it might be right here.
-4.
So here my rise is 1, 2, 3, 4. We're going down 4, so it's -4. And my run, 1, 2, 3. So here my slope is -4 over 3 x minus 2. So that's the equation. Oh, I don't want to do that. So one equation there. Oh. Well, that sucks. Lost it. So there's two equations. Okay. So look at our equations now.
Yeah.
I did a negative, so it's a little bit low. Emphasize it. Okay, so we got y is equal to 3/4 x plus 1. Y is equal to -4 over 3 plus minus 2. So what similarities or what pattern have you noticed here between these two equations? Michael? The rise and run are flipped. Rise and run are flipped. Is it just flipped though? Veronica?
They switched
Yeah, and the signs are switched. Well, I liked how rise and runner flipped. How can we describe that another way, just by looking at the numbers? Huh? Yeah. So we just said what is reciprocated? No, but what here? Well, what part of the equation is flipped?
The slope.
The slope, right? So really, what I'm saying is the slope is the slopes are negative reciprocals. So we take the slope. What that means is, well, we take the reciprocal of it, and sort of changing the signs means that we're just taking the negative of it. So here's the 2 points, the key points that we want to make. So perpendicular lines meet at a 90-degree angle. So sort of definition of perpendicular lines. I think you might have this down already. The perpendicular lines have slopes that are negative reciprocals of one another. So, layman's term, flip the fraction, change the sign. So the symbol would be something like line 1 is perpendicular to line 2. So it's like an upside down T almost. Okay, so that's how you indicate perpendicular.
Would we have to write that at the end of like a question? If it was like, if the question was, are the lines perpendicular?
Perpendicular. I can't even spell that. Perpendicular. Well, if the question, Galvin, was describe the 2 lines, right? And you want to say they're perpendicular, you could write down perpendicular, or you can use a symbol, right? If you're asking if they're perpendicular, then you can just say yes or no. Okay, everybody have this down? I think you guys didn't have to write it. You guys are lucky. I can make another class write it.
Well, we have to write like 3 fills.
Yeah, you're gonna have to write the whole sentences. Okay, so go to example 1, right? So now we know let's think about perpendicular lines and how the slopes are related. Let's look at these pairs of lines. So it's the first one. Are these lines perpendicular?
Yeah.
How come?
Because 3 over 1, 1 over 3.
Yeah, so 3, we have one side, and then we have negative 1/3. So that is the negative reciprocal. What about the next one? No, how come?
Oh,
So we're looking at 3/5.
Oh, you wait, no, wait.
Oh, wait, back the truck up. Actually, it's supposed to be beep, beep, beep. Back the truck up. Right? Why do we want to wait? What's going on here? Aaron? Well, yeah, we need this one.
But it's still one.
We need this equation to slope-intercept form first. Right?
no.
Okay, well first let's work that out. Y is equal to 10x over 6 minus 3 over 6. So y is equal to 5 over 3 x minus 1/2. Once I simplify it,
It has to be negative.
yeah. So here we need 3/5. We want the negative reciprocal of that is negative 5 over 3, which is not equal to 5 over 3. So therefore, no. That one's off. Okay, how about the last one? You guys are so smart.
No.
How many people say yes, they're perpendicular? Raise their hand. Okay. That needs some more time to think about? Okay. Give you a minute to think about it. Pick it up. So how many people say yes, they're perpendicular? Raise your hand. How many people say no? Did you just raise your hand twice?
No, I'm
Oh, okay.
and then like
Just checking. Okay, oh, some of us are undecided, so just go through the same thing. What's the slope of this one? Slope is just 1. Well, here, is it a slope-intercept form?
Oh.
No. So how are we going to get a slope-intercept form?
Get the y.
We have to isolate for y, so how to get y by itself on this side? Sorry? Subtract x? So I want to subtract x from both sides, so we get 0 is equal to 0 minus x, which is really 0 is equal to minus x. I mean, y is equal to negative x. So what's my slope of this one? Negative what? Negative 1. So is negative 1 the negative reciprocal of 1? Well, let's just take 1. What's 1 as a fraction? 1 over 1, I'm going to flip that. It's just 1 over 1. And take a negative of that, which is negative 1. So these two are perpendicular. Okay? So that one was a little bit tricky, only because 1 and negative 1 weren't really fractions. Okay? That's the only number where you get the reciprocal is the same number, is 1. 1 is the only number where you reciprocate it, you get the same number. That's why that one was tricky. That's my goal. 5 minutes. So here, I think it's the last example we'll get through. Is there more than that? Well, I just want to get through this one. Okay. So find the line perpendicular to y is equal to negative 35x minus 6. So we're given this line, right, this equation, y is equal to negative 3x minus 6. We want a line that's perpendicular to that. So in other words, so let's say this one has a negative slope. So this line is going to look something like that. We want a line that's perpendicular to it, right? So even this helps you visually do it. You don't need the grid. You want a line that's perpendicular to that. You want this blue line that passes through the point 6, 9. Okay? So in other words, we want to find the equation of the blue line. Okay, we can make 6, 9 somewhere up here. Okay. That visually helps you see what we're doing. Then do that. Here we got the red line. So we said that this is y is equal to minus 3/5 x minus 6. So how do we go about finding the equation for the blue line? You know it?
Y equals mx minus x.
Well, let's start off first with the equation. Start from step 1. So y is equal to mx plus b. So you're saying that the y-intercept is minus 6? Well, that's the y-intercept of the red line.
Yeah, but since they're perpendicular.
Just because they're perpendicular doesn't mean that they will cross at the y-axis. Okay? Right? Because they can be perpendicular anywhere. I could have drawn this perpendicular line if I used green. There's a whole bunch of lines that are perpendicular to the red line. right? But we want the one that passes through there.
So it's 9.
We don't know what the y-intercept is because it's 6, 9. So if it was 0, 9, then yes, right? Then we know the y-intercept. So the thing is, we don't know the y-intercept on this one, so that's a troubling part.
I guess. Is it 3?
I don't know, but we'll figure it out.
Do we replace
I
five
think it's 3.
We could replace 9 in the equation. What's the first thing we want to do first, though? Yeah, can we figure out what the slope of this, the blue line is? How do we figure out the slope? Yeah, so we want to take the negative reciprocal of this. So negative 5/3. So we want to take the negative reciprocal, right? So when we reciprocate negative 3/5, we got minus 5/3. Take the negative of that, we just got 5/3. So that's our slope of this line. Right? So we got half the problem solved. We got the slope. How do we get the y-intercept now? Ron?
Those points.
Yeah.
6 and 9.
Because we know that 6, 9 passes through this line, right? We can plug in. Well then, when x is 6, what's the value of y? 9. Now we just solve for b. So here, I can reduce that. So 9 is equal to 10 plus b. Subtract 10 from both sides. Negative b is equal to -1. So not quite 3.
It's guess.
So therefore, the equation is y is equal to, so our slope is 5/3, and our y-intercept is -1. We just figured out how to break. This one would have been a tough one to graph, I think. But we'll get a precise answer with algebra. Okay. Any questions on this?
Wait, can you just
Well, this one's kind of easy.
Wait, can you go back? I just-
So the next two examples, I'll leave it for you to do for homework, because I'll just look at it pretty easy.
Next one also.
So this one, do for homework, example 3. Oh, there's only one example left.
No,
Oh, don't do the final challenge.
Why not?
If you want to, go ahead, knock yourself out. Alright? It's a good challenge. It's not required though.